Good morning students. Today we are going to discuss very important topic from chapter work, energy and power, collision. Now what is collision? Let me try to define. Now as per the statement, the term collision refers to the interaction between two bodies or particles. Two bodies or particles. Whenever there is an interaction, we will say there is a collision. Now let me continue. The term collision refers to the interaction between two bodies or particles due to which the direction and magnitude of the velocity of colliding bodies or particles change. So the direction as well as magnitude of the colliding particles will change due to interaction, and that one is nothing but is your collision. Now regarding classification, there are two types of collision. One is your elastic collision and another one is your inelastic collision. Now a collision is said to be elastic if both kinetic energy and momentum remain conserved. So if kinetic energy and momentum remain conserved during collision, it means the total momentum before collision should be equal to the total momentum after collision, or total energy before collision equal to total energy after collision. Then that type of collision can be defined as your elastic collision. And if only the momentum is conserved but kinetic energy is not conserved, then the collision is said to be inelastic collision. Now in our syllabus you do have a elastic collision in one dimension. Now in the figure you see two objects A and B of mass m1 and m2 moves with velocity u1 and u2 before collision. Now during collision there is an interaction between the two mass, and the interaction is nothing but some kind of force. F12 is the force exerts on 1 by 2 and F21 is the force exerted on 2 by 1. 2 we have defined mass m2 and 1 we have defined mass m1. Now after collision they move with different velocity, that is your v1 and v2. Now as the collision is elastic, so therefore total momentum before collision should be equal to the total momentum after collision. So m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So if we take the term m1 in one side, then it becomes your u1 minus v1 within bracket then m1, and m2 equal m2 within bracket v2 minus u2. Now as per the energy conservation, total energy before collision, that is your half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. So m1 u1 square minus v1 square, m2 v2 square minus u2 square. So a square minus b square formula, a plus b, a minus b. So m1 u1 plus v1, u1 minus v1, m2 v2 minus u2, v2 plus u2. So that is your number 1 and number 2. So if we divide 2 by 1, then you will get u1 plus v1 equal to u2 plus v2, or you can say u1 minus u2 equal to v2 minus v1. So u1 minus u2 says relative velocity of approach, and v2 minus v1 says relative velocity of separation. Okay, so in elastic collision basically this happens. Relative velocity of approach should be equal to the relative velocity of separation. Now we are interested in defining the velocity v1 v2 after collision. So to define v1 v2, what we will do, we will use 1 and number 3, 1 and 3, and we are going to substitute v1 from 3 to 1, then we will get v2. And if we substitute v2 from 3 to 1, then we will get v1. So this is your from 1 and 3. So here what we have done, we have substituted v1 from 3. v1 from 3, it's your v2 minus within bracket u1 minus u2. So v2, you see the expression which we have substituted, that is your 3 in 1. So m1 e1 v1 is your v2 minus e1 plus e2 from 3. So on substituting and simplifying, we are getting v2 is your 2m1 e1 plus u2 m2 minus m1 by m1 plus m2. So you check out this one. So again we have substituted v2 in 3. So if you substitute v2 in 3, you will get v1. So again this one 3 and 4. So on simplifying, You check out the simplification part. It's a very simple mathematics. On simplifying, we have got V1 as your U1 M1 minus M2 plus 2M2 U2 by M1 plus M2. So you check out the calculation part. So to defining V2, we have substituted V1 from 3 in 1, and on defining V1, what we have done, we have substituted V2 from 4 in 3. So that's why we've written from 3 and 4, and we have got the final expression is this one for V1, and final expression is this one for V2. So these are the two velocities after collision. Now under note, we are trying to consider few cases. You can consider some more cases as far your textbook is concerned. So if two objects are of same mass, if M1 equal to M2, then what will happen about V1 and V2? So if M1 equal to M2, then V1 will be your 2M2 U2 by M1 plus M2. You can further simplify substituting M1 equal to M2 equal to M. Then you will get that it is nothing but easier. If you substitute M1 equal to M2 equal to M, then 2M U2 by 2M. So 2M to M goes off. So V1 equal to U2. You can further simplify. Similarly, V2, if M1 equal to M2, then you will get 2M1 U1 by M1 plus M2. So here you can substitute, then you will get V2 equal to U1. So V1 equal to U2, V2 equal to U1. If you consider M1 equal to M2 equal to M, say. So it means the exchange of velocities occur if the masses are identical. So V1 is your U2 and V2 is your U1. Now if you consider initially one object is at rest, another one is moving. If you consider U2 is at rest, then you can substitute U2 equal to 0, then 2M1 U1 by M1 plus M2 for V2, and U2 equal to 0, if you substitute, then U1 M1 minus M2 by M1 plus M2. So these are the possible cases, two cases. You can consider some more cases. If M1 greater than M2 or if M2 greater than M1, what will happen? But the main formula for the velocity is this one, V1 equal to U1 M1 minus M2 plus 2M2 U2 by M1 plus M2. You just try to substitute this expression and try to find out V1 and V2 on simplification. So again, V2 equal to 2M1 U1 plus U2 M2 minus M1 by M1 plus M2. So please go through, these are the mathematics, simple mathematics, and try to calculate and simplify. And these expressions are very important for the numericals. Thank you.